Bring it.
Okay, welcome to this talk. It's done by Dan Kawinski, who came here from Seattle. He's coming to CCC events for the last 4 years now, and this time we'll find very interesting stuff that he seemed to have found when he cleaned up his attic. I hope it will be very interesting and funny, and I'm convinced that it is, because I've seen some of the stuff at the camp this summer. So have a lot of fun.
Testing, testing. Do I actually have working sound here? Yes. Sweetness. All right, everyone. My name's Dan Kawinski. I am incredibly happy to be back out here again for CCC. It is a long flight, but this is such one of my favorite cons every year. So thank you, everyone, for coming out. As some of you might know me, I do like the pretty pictures. These pretty pictures are actually audio visualization that has nothing at all to do with this talk. However, if you happen to be interested in audio visualization or know someone who is, please find me after, because I have things to ask you about. Like, what the hell am I supposed to be doing here? Because it ain't this. All right, so let's talk for a minute. Oh, by the way, that stuff I was showing, was anyone here at my talk last year where I was talking about dot plots? I kind of sort of ported all that to Winamp. And it works. I was really drunk when I started writing it. Especially when I'm like, this isn't supposed to work yet. Anyway, so what I'm here to talk about for this con actually is, well, for most of my talks, I do various stuff at various networking layers. This is the 7th time I've done a Black Ops, a TCP/IP talk. I really should come up with a new name, but I like it. I don't know what to say about that. I've talked about lots of different things, SSH and high-speed network scanning and DNS and more DNS and more DNS, yes, this is true. Some pattern analysis stuff, been playing a little bit with network neutrality research. I finally decided after all these years, all right, it's time I finally mess with the web. What finally got me to look at it? Oh dear God, it's huge. There is so much crap in web browsers. I had no idea. It's beautiful. And wait, Apple people, I'm not being light on you. The best part is I was totally gonna Photoshop that to look like the iPhone, and then I'm looking at the frame, I'm like, I don't need to do anything. So the web really is where the wild things are nowadays. You know, the amount of websites out there with cross-site scripting is just absurd. It's, you know, you hear numbers up to like 70 to 80%, and honestly, it's probably an underestimation. The web's turned into a way to distribute worms nowadays. There was a malicious WMF file that was put on the website of the Super Bowl. It actually infected, I think it was 3 or 4 million people. We haven't seen 3 to 4 million infection rates in several years. It's back. Ad networks are getting hit like nothing has been hit in a long, long time. But what really got me to start looking at the web was this thing called the DNS rebinding test by a guy named Dan Benet over at Stanford. What Dan went ahead and did was he was playing around with Flash, he and his team, and they put a Flash applet on an ad network. And overnight, for $50, they got into 100,000 networks. 50. Yeah. So there are a few key words here. We had DNS, we had tunneling, we had behind firewalls. All right, I gotta get me some of this. This is such my domain. So I'm like, okay, let's see what is going on here and see if there's any kind of interesting stuff that I can take a look at. It turns out DNS rebinding is an old bug, like 1996 old. Like so old, they forgot about the bug and put it back. Oh. A ton of people have actually been going into this. I'm not the only one. Benet at Stanford's been driving the most thorough research, been writing the papers, but the attack dates back to 1996. I mean, we call it the Princeton attack because we have no idea who those undergrads were who found it. The guy who set back off the research of this was Martin Johns, who's somewhere around here. He revived the attack in August 2006, and Snake of the hackers.org blog also has been driving a lot of interest in its general direction. DNS rebinding, small little DNS bug, totally breaks the security model of the web. What do I mean by that? Well, kind of an introduction to the way that the web works. Web pages, they're not unitary things. They're not like an atomic, I have the web page, it is one file. No. Web pages are pretty much pulled together at the time they are loaded. You might have your page from here and your ads from there and your images from here and your music from there. They're pulled together. Average websites on like 10 different servers. On the web, you can even have an entire second web page and another web browser inside your main browser. This is called an iframe, an internal frame. This embedding facility, if you think about it for just a moment, this could be really dangerous. What if you go to some random website and there's Hotmail in there? They embed Hotmail. And what if you were already logged into Hotmail? This iframe, it's another web browser, but it's on someone's page. Could they use JavaScript? Could they go inside? Could they script your Hotmail? Could they read your messages? Could they impersonate you? Could they basically be you just because they put Hotmail inside, www.attacker.com? Well, it turns out they thought of this, and they created a policy. They call it the same origin policy. You all can think of it as look, but don't touch. The idea is that you can go ahead and you can embed other people's resources. You can even embed other people's websites. And you can show it to the user. And the user can click and do everything normally from the user perspective. But from JavaScript, no. You can show it to the user, but you don't get to look inside, poke inside, read their mail, write the mail. The user can do what they want. The user can do things, but the software outside, the surrounding page, it is limited. That is the security model. And the idea is that foo.com can look inside foo.com's resources, but can't look inside bar.com's. So if you go to like an attacker's website and they embed Hotmail, well, can't look inside, sorry. The security policy seems so very logical. If two things come from the same place, well, they must be trusted the same. All right. Well, the same place should be the same name, right? Right? No. Names don't actually host anything on the internet. Everything comes from IP addresses. Now, we use DNS, my favorite protocol of all time, to translate between a name we trust and the IP address we're actually going to communicate with. And you might say, well, foo.com's over at 1234. Bar.com's over at 3456, and never the twain shall switch or change or no. Bar.com can return whatever the hell it feels like. So, you can go over to bar.com, and it can return its own IP addresses, or it could return somebody else's. DNS makes no guarantees about the ownership of IP addresses. So let's think about what that actually means. So at one point, bar.com can refer to some server, out here, this is really an Americentric slide now that I think of it. That faraway mystical land of Europe. S, Europe, China, G. Okay. So, one moment, bar.com points at a server in. There you go. You guys are awesome. The next moment, no, that's the printer down the hall, out here in Europe. Now, suppose for a moment your browser loads a page from out in China, And some research from the page out in China says, hey, I need to get something else. Only now it doesn't come from out in China, now it comes from your printer. It's an iframe of the printer. Well, now script from China is able to script against the printer and is able to drive it as if it was local. Now, IP was built to think, we have a global address space, there are no firewalls, if I can reach it, you can reach it, everyone can reach it, it's a big party of reachability. Yeah, that's not the real world. Real world is totally about islands of connectivity with very well-defined interfaces. Unfortunately, these bugs involve, I may not be able to reach your printer, but you can, and I'm going to bounce off of you to get to these internal resources that I don't normally have access to. So why does this work? What is going on here? This seems like a pretty obvious bug. Well, the deal is that the browser has no idea that bar.com from an external IP out in China is any different than bar.com from an internal IP printer down the hall. This is by design. Design bugs, a little bit of an offshoot. Design bugs are the best bugs ever. No one ever takes a dependency on a buffer overflow. No one's like, man, this code really needs to crash or we're screwed. People take dependencies on design bugs all the time. If you look at Google, if you look at actually any major website and you do DNS lookups on them, you will often see that you get back a whole list of IP addresses, any of which will theoretically provide Google's content. And this is by design, this is necessary. You need what's called DNS failover. If one IP fails, try the next. Nowhere does it say that these other IPs that you try are actually going to be Google. Thus the bug. Google can return whatever IP they want. Bad guy can return whatever IP they want, and you, the browser, have to accept it, because it might be real. And you don't want errors, scripting error, Google has a new IP. Google has 10,000 IPs. Yes, they have a new IP. So, yes, the very easy ways of detecting that a script has gone from one IP to the next. What the hell do you do about it then? Therein lies the problem. So let's talk about the canonical attacks here. Canonical attack is actually firewall bypass. Most corporate networks draw a significant distinction between the external network full of bad guys and the internal network that is, of course, totally safe. Of course. Hey, we deal in optimizations. The very, very simple firewall rule set, things on the inside can go out wherever they want, but if you're on the outside, you're just not coming in. Well, by bouncing off a lured web browser, an attacker on the outside can reach resources on the inside. Levels of exploitation. Let's talk about what it means to actually reach inside. Well, the basic level of exploitation is there are no plugins involved. You just use the web browser. One iframe's out in China, the other's in the printer down the hall, and the two iframes are able to script against each other because they're both badguy.com. There's no plugins, there's no magic. You just use the browser as it is. Oh dear God, this is going to be miserable to fix. It wins you arbitrary HTTP sites. Level 2 actually starts getting into some of the plugins that are available. MSXML, XML HTTP requests, Silverlight. These things actually give you a little bit more control at the HTTP layer. You start being able to add a few headers. You start being able to interact with web services. For those of you who might actually be working inside of some companies, you might see, wow, instead of RPC, we're moving everything to XML because XML is magically awesome. It must be safe. It has angle brackets. Please stop writing crappy XML parsers. Please, please, please. Web plugins are awesome and cool and will break all sorts of things, but no. Forget restrictions. Let's just play with the real stuff. We have plugins in 90% of browsers that just give us raw sockets. Java will actually give us both TCP and UDP. Flash, which is even more well deployed, gives us TCP sockets. Now we're not restricted to things on the web. You can like talk to database servers, you can talk RDP, you can talk SMB. If it's like on your network, it can pretty much be spoken to. Let's go through these plugins. Java. Java was the original target of the 1996 Princeton attack. And man, these guys, they did not forget. They actually worked their ass off, and they built a protection in their applet security layer that had not been broken for 11 years. It was broken like a month and a half ago, but had not been broken for 11 years. However, and this is instructive from watching what goes wrong in security, big, huge security system over here. Little tiny backdoor that went all the way around it. There were two ways of reaching the socket code in Java. One was the applet security interface, which was mostly safe. The other, unfortunately, was something called Live Connect, where directly from JavaScript, you could say, I want to create a Java socket, and it would do it. And it would do it completely independently of this big, huge, expensive security layer that they had built. I hate it when it happens, and it happens more often than you guys know. The problem is Java's solution for the applet security interface was they are going to download their code, and they're going to know the IP address their code came from. And if it came from 1.2.3.4, they are only making connections to 1.2.3.4. Doesn't matter what DNS said, they loaded the code from an address, that's where they're creating socket connections to. Great. Unfortunately, when the browser says, give me a socket to this place, they have no idea where the browser got its stuff. Browser could have gotten its stuff from like anywhere in the world. And so it just said, oh, I guess I have to do a DNS lookup. Crap. Luckily, this only worked in Firefox and Safari. Flash. I feel so bad for Adobe. These guys tried so hard to build this entire complex security model, and this bug from 11 years ago just goes tunnels underneath all of it. Yeah, they had the most mature security model in the industry, and rebinding just broke them 83 ways from Sunday. About Java, by the way, Java has fixed their stuff. They pretty much broke the hell out of their stuff, but they fixed it. We'll talk about Flash later. They're trying. I wish that was good enough. So, there are lots of ways of using a rebind, but how do you actually do this in the first place? What does it mean to take an address from 1.2.3.4 and move it to 10.0.0.1? What's going on anyway? Well, there are not just one. Turns out there are 3 ways, and probably more, but we'll just talk about 3 ways of moving an address from out in China to, printer down the hall. The first way is temporal, the second way is spatial, the third way is just ridiculous. First way, temporal modulation. This is the one that everyone's been talking about. Well, by design in DNS, you just get to say, yeah, this record that I'm giving you, it's valid for now. If you need a record later, do another lookup. It might change. Shockingly enough, it might actually change. That's the exact feature we're looking for. DNS specifically supports rebinding. Awesome. So yeah, you basically advertise every time you're hosting a record. You say, yeah, don't cache it. Just ask for a new one each time, and it will. So your host goes get something at one place, and it resolves to China. And it looks up again, and it resolves to printer down the hall. Very, very easy. Now, there are some networks that say, we don't respect low TTLs. We're going to hold on to a record for at least 5 minutes. Because, hackers can't wait 5 minutes. This is why there are 3 methods and not 1. Because I'm like, all right, you guys want to see what kind of trouble you're in? Let's play. DNS is pretty flexible. You can return 2 records at the same time. And you just go ahead and be like, yeah, this server, it is simultaneously in China and down the hall. Wow! Browser's like, I'm gonna pick one. And you know what? It totally might pick the wrong one. And you know what you do then? You try again. Works like a charm. I'm not going to go into the whole mechanism of trying again, but in case you're curious, here's how you do it. Now here's where I start having fun. You know, people were trying to use DNS-TTL as a security technology. Let me tell you, whenever you try to use something that's not a security technology as a security technology, it never ends well. These things were not, they were intended as an optimization, a way of controlling caches. Let's say you do actually have something in cache, and let's say it's sitting around. Is there any way of overwriting something in cache? Well, it turns out there totally is. When you do a DNS lookup, you do not necessarily get back an address. You can, in fact, get an alias, something called a CNAME, a canonical name. If you are allowed to be the resolver for a given name, you are allowed to return CNAMEs as well. You can return these aliases. This is not a bug. This is a feature. This is a core way that DNS works. Let's take a look what happens. We're going to use this tool, dig the, domain internet groper. Fantastic name, really. And we're going to look up the name one.foo.notmallory.com. Mallory being the custom cryptographic name for like your man in the middle, your bad guy. We know this is safe because it's not Mallory. So we look up one.foo.notmallory.com, and we get, oh yeah, that's at bar.foo.notmallory.com. And because I'm allowed to tell you, bar.foo.notmallory.com is at 10:00. And now, we look up bar.foo.notmallory.com, and it goes, yeah, 10:00, that's what I got for bar.foo.notmallory. But now immediately after, we're going to look up 2.foo.notmallory.com. Totally different name. But it too is going to return a CNAME for bar.foo.notmallory.com. But now it's going to say it's at 10:01. Even though we had something in cache for bar.foo.notmallory at 10:00, now because of this new record that's been looked up, bar.foo.notmallory.com, yeah, that's moved over to 10:01. It is not hard to override entries that are in cache. There's like a ton of other methods. So let's review. By swapping addresses out from underneath a web browser, we can get arbitrary TCP and even sometimes UDP access to hosts reachable by the client. Well, what can we do with this? Can we play some games, write some crazy JavaScript SQL clients? Oh God, I don't want to do that. I have SQL clients. Can't we just hook them up? Yeah. I was thinking, why don't we just full-on set up a VPN connection to corporate network using nothing but a Lord web browser? Totally easy. Actually, no, it was an utter pain in the ass. Took like 7 programming languages and 6 protocols. Okay, can I just whine here? What is it about web programming? Every time you sneeze, you're in a new programming language. Make up your mind! Really annoying. All right, we got 3 actors in this little dance. We got a browser that has access to internal resources. We got an attacker that wants access to internal resources. And we got a proxy that's got to hook the two together. Well, we're going to start with a proxy, running some software that I wrote. It's called Slurpee. The name will be obvious in like 10 or 15 slides. And a few small people in this room will hate me forever for it. The basic theme of Slurpee is that the attacker is going to connect to the proxy. It's going to manage the appropriate resources in the browser to service the attacker's connections. We do this using what I refer to as a bucket of sockets. The browser is going to connect. It is going to create a unified connection manager for all endpoints they're copying to. AV question, can someone come up and give me internet connectivity? Crap. So a browser is going to connect, create a unified connection manager for all endpoints. I call this a bucket. The bucket is going to poll Slurpee and is going to ask, hey, you have any connections for me? Eventually, the answer is going to be yes. I do, in fact, have connections. And what's going to happen is the bucket is going to open another iframe inside of it. It's called a socket. A socket's like a socket, but it sucks. Seriously, it's really slow. It is this second iframe is hosted actually at a different domain. It's hosted at, say, 10.001 foo.proxydomain.com. This is for a specific reason. I'll have to explain why later. Now, when I say poll, let's take a look at what's actually happening over HTTP. We have, 10.001, connection 3. We have some sequence numbers. We have, some port data. We have some data that's to be sent to the browser. Yeah, I totally ported TCP to JavaScript. They knew what they were doing. What can I say? So, the browser at this point has found out, hey, I've got some data to send. It is the base 64 decoded equivalent of, the 0 block, the 1 block, the 2 block, and the 3 block. Great. Let's go ahead and do something with this. Well, okay, I've got this second level iframe. I've got this socket. What's it going to do? It can't open any kind of socket connection by itself. It needs the help of Flash. And I don't know about you, I ain't going ahead and dealing with some huge Flash IDE. There's this great thing. The guy who wrote it is here. He's my hero. It's called Hacks. I had to use it just for the name. It's an open source, totally straightforward environment for messing around with Flash APIs without the inconvenience of, actually having the IDE around. Not only do you get all of those goodness, you actually get this really nice layer in which a, HTML document with JavaScript can go ahead and call functions inside of Flash. Given that I need Flash functions to actually send and receive data, this is perfect. So, we're going to have each of our socket iframes open a Flash Swift file compiled by Hacks. So, important question, how many DNS requests does it take to get to the center of your corporate network? Well, first what's going to happen is that we're going to retrieve socket.swift from HTTP attacker. And DNS is going to reply, oh yeah, attacker, that's at 6666. Great. Now, because we got to deal with Flash, Adobe, it's got its security policy. It wants to get a socket security policy that says, yes, it is okay to open a socket wherever you like. And this is actually going to also go to XML socket, because they got their own protocol, attacker. And that's also going to say 6666, no problem. But now, we're going to try to create a socket. We're going to try to make a connection. Again, to attacker, same name. Different port, but same name. But we're going to go again, a third time to DNS. And this third time, no, now we're saying it's 10.001. And we end up with the script from the Swift from 6666, the socket policy from 6666, the connection to the printer down the hall. Works great. And if I do actually get net here, I will give you a demo, but unfortunately I don't seem to have Ethernet back here by any way. So, oh well. At this point, the data flows are fairly straightforward. Flash is going to go ahead, get data on a socket. It's going to try to send the data from the Flash movie down into the iframe of the socket. The bucket is going to visit each of the sockets and be like, you have any data, you have any data, you have any data. It's going to aggregate all the data that needs to be sent back to the proxy. It's eventually going to get it, say proxy, all right, this socket's got these bytes to send, this socket's got these bytes to send, this socket's got these bytes to send. Gives it to the proxy. Proxy's like, hey attacker, I got goodies for you. He hands it over to the attacker. Attacker goes ahead, replies with, great, send these bytes over, and it's just the reverse of that. And it's basically at that point a very simple TCP to JSON aggregation layer. Works like a charm. Domains. One of the things I mentioned earlier is that those sockets inside the bucket, they're actually at different domains. There's say 10.001 foo.proxyhost.com, 6041.64.139, foo.proxyhost.com. They're different domains. Why are they allowed to script? Why are they allowed to push up into their parent bucket? Well, it turns out there's a very nice little exception in the same origin policy that says two things under the same subdomain can opt in. They can choose to allow each other to script. Well, we're going to use the same origin policy to defeat the same origin policy. Sweet. So we basically just say that. We say all these child sockets, yeah, if the bucket wants to go ahead, poke inside, pull out some data that it really shouldn't have access to, no problem. That's it. A little bit of housekeeping for opening and closing sockets. And we've pretty much just implemented TCP and JavaScript. Now, what about the attacker, though? What's the attacker going to do? How's he going to open sockets? Well, has anyone at all remember Slurp? My people. Slurp was old school when I first talked about it 6 years ago in 2001. Slurp was NAT in 1995. Back in the day, we didn't have your newfangled broadband. We didn't even have dial-up. No, we had a text connection to a bank of modems connected to Unix servers. And all we had were these so-called shell accounts. There was no ability to route packets. There was no DHCP or getting an IP address. You had text. And then Mozilla happened. And Mozilla rendered JPEGs, which made it really important to be able to get access. So, Slurp would take your text link and would turn it into a way for Mozilla to connect. Awesome. Well, about 6 years ago, I was looking at Slurp, and I'm like, I can use this. I can use this to make my very own special VPN concentrator using SSH. And it was a big, hairy mess, and it involved a protocol by the name of PPTP. PPTP may very well be the world's most hideous protocol. The only competition I know of, well, okay, with the exception of anything in the SCADA world, you guys win, with the possible exception of SMB. Oh, dear God. But no, seriously, if you ever wrap your mind around PPTP, you'll end up with like TCP over IP over PPP over GRE back over IP with a TCP control channel. It's not good. It does not get tunneled over DNS, but that's just because I wasn't involved. All right. So it turns out you can't even get the most recent versions of Slurp. They disappeared from the web. I had to pull an old hard drive out of storage. What it actually does is, given a stream of packets, it will interpret the stream of packets as connection requests and actually turn them back from packets to connect here, send this data there, close this socket, and so on. It's actually very, very impressive and very useful. So, PopTop was the Linux PPTP daemon. Again, not going to talk about the details of PPTP, but what PopTop will do is it'll take a PPP stream emitted out of Windows, and it will hand it to whatever PPTP daemon you have. In this case, Slurp. Now, normally, Slurp would go ahead and upon receiving these connection requests, it would create its own sockets. It would run connect, it would run bind, it would do this, it would do that. Now, what if instead of creating its own sockets, what if it gave it, say, to a proxy by the name of Slurpy? So-called Slurpy because Slurpy is the connection between Slurp and IE. The attacker runs applications that use sockets. The sockets get their traffic sent over PPTP to Slurp. Slurp provides the set of streams to the proxy. The proxy tells the browser bucket to open the appropriate sockets. The browser opens the sockets, which themselves provide sockets, and the proxy mediates the traffic between the attacker's sockets and the browser's sockets, and it all just works. No more custom tools in the browser. You want to run Nessus over IE? You got Nessie. You want to run World of Warcraft over IE? You got Wowie. If it's TCP, it'll work. That's what I've been playing with. So, impacts. Well, corporate firewalls are kind of hosed. They're bypassable through lowered browsers, which themselves are really, really accessible via ad networks. There is a special case that needs to be brought up because it doesn't even require Flash. You can do this just from your standard browser. How many of you guys have like Linksys routers at home? Like, you know, little devices that give you wireless, a little web management interface? If you're raising your hand, please change the default password on your home router. Because your home router is accessible from your desktop, and your desktop is accessible from ads on the internet. Ad on the internet bounces off of you, goes to your home router, has a bidirectional communication channel. This used to be referred to as the drive-by attack because you used to be able to have image links that would blindly say, yeah, I'd like to download a file from HTTP 192.168.11/ username, admin, password, admin, new DNS server 1234, and it would work. Okay, they fixed this, not by getting rid of default passwords. They fixed this by making it so there needed to be a bidirectional communication between the client and the server. And unfortunately, these DNS rebinding bugs provide a bidirectional communication from the client to the server. It is unpretty. So every browser is now a proxy. There's no botnet necessary to get mad connectivity. If you view an ad, you are now a proxy server. Have a nice day. Every browser can send spam, SMTP, HTTP. Every browser can log into instant messaging networks. Every browser can proxy click fraud. This is, as we say, not a good thing. Google has been losing a lot of money to it. They are going to be losing more. Ideally, you have your big network of IPs you don't pay for ads for. Unfortunately, now every single browser is a route to these attacks. This is not good. There are other things that we can do. Stealth Tor. You know, I like Tor. I know Roger. I help him build stuff. But, you know, I'd like consent to join the Tor network. I would not like to go to websites and suddenly find myself a Tor end node. I can now, unfortunately. We can do some stuff with network neutrality. Oh, peer-to-peer networking. Java gives us UDP, or at least did before they went Nazi and fixed everything. No, I'm serious. I've not seen a breaking change like this in a while. It's called no one was using the functionality at all. To Adobe's credit, they don't have that luxury. UDP sockets are simultaneously clients and servers, so it looked like we could go ahead and have a full peer-to-peer network just between web browsers that came to our website. Sweet. There's a little more. I am not ashamed to admit I was smashed off my ass when I came up with this. On stage at DEF CON 14, TCP/IP drinking game, best thing ever. And I am asked, how would I get around the Great Firewall of China? Now, the answer that I was supposed to provide is, well, I would ignore reset packets, and that way the Great Firewall of China, when it sent me these fake resets, I would ignore them and I would be able to get through. But you see, the question was, how would I get around the Great Firewall of China, which is totally a different answer. I'm like, well, China, well, they send a lot of spam. They receive a lot of spam. By my judgment, that's a high bandwidth, low latency channel. Oh, sweetness and light. All right, we're going to do this in a way that violates every rule of what I know about giving a presentation, which is I'm going to set this up from scratch while attempting to continue my talk. And Elisa, get up here. Get up here. This is some rock star getting the net set up during the talk. Everyone,
actually, Aryan did up there.
The Network Angels are the shit. They have never let me down in 4 years. All right, so check it out. While I try to set this up, like, well, look, you've got all these servers, you've got all this spam coming in, you got all this spam going out. It's high bandwidth. It's coming in and out at least like every 10 milliseconds, so it's low latency. Oh yeah. Some of you get where I'm going here. I'm like, let's encapsulate all of our traffic in Viagra. Perfect. Well, so again, I was originally joking, then I'm looking at it and I'm like, you know, I have a browser here, and it's got IP traffic inbound, and it's got spam outbound. Ah, shit, I should actually build that. This is disturbing. Am I supposed to be getting DHCP on this, or really? I'm trying. Reno? I gotta admit. You know, and the great thing is how I have shots immediately available. Oh, sweetness. All right. I have more important things. Hey, I will shoot it when the attack actually works. All right, so check it out. I think I have this mostly set up. All right. This is totally not how you do a demo. Step 1, read Penny Arcade. Ha ha ha. We're gonna go ahead, go to our bucket. I am so oh, wait, I know why this is failing. Because I don't trust any of you bastards. No. I would like my DNS to work. There it goes. You know, it's really ironic when DNS doesn't work for me. I actually think it's me getting what I deserve. All right, so check it out here. Do we get a bucket? Oh, we got a bucket. Isn't it beautiful? Design is not my strong suit. All right, so we're gonna go ahead. We have our bucket, it's polling. We're gonna go to the debug interface of our bucket. I'm gonna say, hey, debug interface. Let's actually come up with a, this is such a great ad for unnamed vendor. Let's see, mail.duxparrow.com. This is totally not how you do a demo. Watch. We're gonna go over to our debug interface. I'm gonna say, hey, debug interface, I would like a connection to, and I'm in fact waiting for the rest of that line to complete, to there, port 22, protocol 6, TCP. And now, as we should see in the background, maybe, this net connection's a little, oh, look at it go! No magic. That was just me switching terminals. We see in the background, it is going to load. That is actually the socket. It is the second level iframe. It's got the JSON that I was referring to. Oh, this net is struggling. It's trying so hard. It wants to succeed. I know it. It is attempting to load, maybe? It's totally not how you do a demo. It is actually attempting to load and not doing too great a job of it. In fact, the link seems to be slow or dying. I will hit refresh once on this, and then I'm going to have to move on. This is the joys of live demos. Wait, maybe? Is it actually going to load the... Actually, that looks good. Maybe. Oh, sweet. We have our socket, we have our connection, and in here, wait for it. It is, in fact, yeah! Like I said, it's like a socket, but it sucks. And it's a full bidirectional socket, 8-bit clean. Actually, it was kind of great when I was writing it. I had this bug where it was almost totally working, except like 1 out of 20 packets would get dropped. Okay, this is TCP. It's not supposed to be able to drop packets. I had a threading bug in a web browser. It turns out, consider this a warning, multiple iframes operate as completely independent interpreters. They are actually different threads. I had a bug where one was sending and the other was receiving, the two are desynced. I had to re-architect the damn thing. And I felt good about it. I'm like, sweet, this is gonna come in useful later. Now, I do believe I mentioned that we can use some of these technologies for net neutrality, and this is the point in the talk where things go strange. I was unaware this was such a hot button subject when I talked about making tools to detect network neutrality issues. My net neutrality stuff from last year was great, worked wonderfully. It required you to send so many packets that the link would break. It turns out that's very difficult code to release, though I had enough bandwidth to do it. One thing about net neutrality, we need to stop referring to it as net neutrality. You do not beg for the status quo, thank you very much. I refer to provider hostility. And here's a very good definition of provider hostility. If you're sniffing my traffic, hostile. Altering my traffic, really hostile. Censoring, basically, think of it this way. Would the US military bomb the crap out of you for doing it? You might be hostile. I'm just saying. This stuff is happening. Check this crap out. The goal is to identify the applications being used on the network, but some of these devices can go much further, pick out the HTTP traffic, drill further to capture the traffic going to and from Gmail, and can reassemble emails as they're typed out by the user. What kind of creepy shit is this? Get out of my traffic. Everyone who knows anyone who's dealing with stuff that making routers knows, my God, the carriers want evil stuff. That's what they're buying. That's what they're looking for. There are repeated news articles about ISPs replacing ads, and companies setting themselves, in fact, up as ad replacers. Can we do something to monitor the spread of this? Can we defend? Yeah, you want to talk about weird? Me. I'm getting into the business of saving online advertising. What the shit? So I call this the Times Square effect. If you ever see Times Square in New York City, you are not actually seeing Times Square. All the advertisements have been replaced, because there is no contractual obligation not to replace the ads, and there's money to be made. Well, when you go to Google, your carrier is under no contractual obligation to actually show you the packets that Google was providing. Someone finally realized that man-in-the-middle attacks can be really freaking profitable. And let me tell you, the providers, they like profit. So the deal is with ads, we bitch and moan, most users don't mind. They don't know, they go to a page, there's an ad, maybe they click. They don't know if it was the ad from the page, the ad from somewhere else, and the providers know it. And let me tell you, it's a hell of a lot cheaper to pay the provider to put some stuff on the page. In fact, can you imagine if you could pay $1,000 and be the top link on Google? Because let me tell you, Google won't take your money. You want to be the top link on Google, you gotta do crazy search optimization. Yeah, I got search optimization with a 7-figure check. That's the kind of search optimization that some people would like. And that's the kind of things that people are really looking into because, people like 7-figure checks. So, what do we do to detect provider hostility? What does it mean? Well, downloading data from 2 different sites at 2 different speeds, that doesn't tell us crap. The internet's a big place. There could be an issue anywhere. What we need is, given identical network paths for 2 websites, is the last mile provider hostile to content from one site versus another? Meaning, we've got to take the entire internet and we've got to make it go under the same network path. And then we can start drawing conclusions based on differences in speed and differences in content. Well, let's look at what kind of tricks we can do. Sometimes, when we're on a network, we have a transparent proxy. These things take all traffic outbound, no matter what the IP address is, and if it's port 80, they will move it to a given device, and you'll just talk to that web cache. This is fantastic, because with Flash, we can say, hey, I'm going to get slash from host Google, or host Yahoo, or host MySpace, and it will always go to the same server in the last mile. And if Google goes at one speed, and Yahoo goes at one speed, and MySpace goes at one speed, or if the content is changed for one and not the other, well, we now know that this ISP favors this company and not this company. Perfect. Now, there's only one problem with this. Transparent proxies suck. They're really unstable. They're so unstable that a lot of them got deployed and then pulled back because they just didn't work. Now, that doesn't mean, however, that these sensors can't get in the way. They can go ahead and they can allow you to do all your normal traffic, no proxy in the way, but if they see you trying to go to Google, they see you trying to go to MySpace, then they go ahead and mess with you. Well, we can go ahead and using Flash, we can go to port 80 and say, yeah, test IP, I'm trying to download stuff from Google. And the sensor says, wow, Google's got a new IP. I better go mess with it. And then you bust them that way. There is a problem. Problem is detectability. Now, in every major networking company, I assume there's a protocol guy just as ornery as I am. And he's sitting there like, I'm totally going to detect Dan doing that. Oh, yeah, I know all of Dan's IPs. I see him do all of his scans. I can see his weird-ass packet tricks from a mile away. No problem. So I'm like, all right, I wonder, could I make a net neutrality verifier so good even I couldn't detect it? I figured either way I would win. And indeed I did. Well, let's look at the problem for a second. Internet's big, we're little. There are, in fact, repeated accusations that, for some strange reason, the speed test sites that measure how fast your internet connection is, wow, they're really fast. Only when you're connecting to the speed testing sites. These guys get all the bandwidth, everyone else not so much. A site that is detectable will get messed with. We want to be everyone and anyone as far as the ISP knows. We want to be able to spoof anyone. We don't want the real sites to mess with us, and we really don't want the ISP knowing what we're up to. Well, in order to do this, we would have to spoof traffic. And anyone who knows about spoofing traffic on the internet knows you can have any IP address you want. But to spoof on TCP, you need sequence numbers. And let me tell you, I don't care how crazy the bugs are in Flash. You're not getting a TCP sequence number out of Flash. You aren't getting TCP sequence numbers over JavaScript. I mean, that's just never going to be possible, and oh, hell no. I swear to God, this just makes me happy. It fires a JavaScript event every time you get a packet. It gets the payload of the packet. You can do whatever you want with it. This should not be. All right, now we can do some evil things. Because now, yeah, you can actually go to a website and you can get sequence numbers. I am building a tool. It is called Inspector Packet. Normally, Mallory, our quote-unquote attacker, does not know the sequence number the client will accept. Normally, Mallory has to compete with the real server for sending of the data. Well, let's look at what we have. We have a sniffer that will leak all the sequence numbers that we could possibly have to Mallory, to quote-unquote the attacker. Now, what the attacker do? Attacker has the sequence numbers. Attacker can spoof data. Okay. Attacker spoofs some data. Client gets it. Client's like, great, I got data. Hey, real server, I got data. Isn't that great? Yeah, isn't the real server going to be really unhappy with that? Not if we tell the real server to go away. There's this wonderful thing called a TCP reset. With enough knowledge about a socket, you can forcibly close a socket with a TCP reset packet. It requires the source and destination IP, it requires the source and destination port, it requires the source and destination sequence and acknowledgement number. These are all things our sniffer has so helpfully provided. The reset can be delivered to either side, either the client or the server. So if the attacker sends the real server a reset, it will ignore all traffic from the client. Ah, but wait, it's not supposed to do that. By the RFC, if you receive an acknowledgement on a session that doesn't exist, Clearly something is wrong with the client, and you should be helpful. And you should tell the client, go away, reset, I tell you something is wrong. I love internet security. We have firewalls. Firewalls are like, if you receive an acknowledgement and there is no session, dear God, it must be a hacker, ignore. Close your eyes. Say nothing. Do not interfere. Thank you so much, firewall vendors. I love you guys. So how does this look? The client is going to send some traffic to the server. Server is going to totally ignore it. The attacker is going to send traffic to the client. And as far as the ISP knows, that looks like the server, because it's got the right sequence numbers, it's got the right IP addresses, and the client is accepting it and acknowledging it. Of course it's acknowledging it. It's in on the game. As far as the provider in the middle is concerned, the client is talking directly to the server. Therefore, the client and the quote-unquote attacker can collaborate to make the eavesdropper hear whatever the heck they want. Any changes in content, any changes in behavior are not because of some random stuff happening on the internet. No, that's the last mile, being a little evil. And that is the game. So, conclusions after this fun adventure. DNS rebinding sucks. Totally screwing with your firewalls. If I could say one thing, please, if you have a home router, change the default passwords. In fact, change default passwords if you have them anywhere. They're all hosed. We got to start worrying about ISPs being evil, because it turns out it's really profitable and they like profit. There are mechanisms for detecting evilness, and they will be deployed shortly. To anyone who works for an ISP, consider this fair warning. I am done and open for questions. All right, anyone got a question for me? All right, I'm going to stand still. Go ahead. Oh, here we are. Cool. We need some mic help here.
Hello?
Yeah.
This two-way bidirectional channel will only hold while the browser is open on the evil page, or will it stand, like, do you like demonize it or have something?
Great question. So you're referring to the actual proxy, right?
Yes, yes.
All right. So the proxy will only stay up as long as the actual page is open. What Dan Benet found during his test was he was actually able to get a surprising percentage of the people who browsed him to stay open for at least 12 hours. So it turns out that if you do pop under ads, those really annoying things that sit under your browser, people will just leave them there because they're designed to be left there. That's the whole idea. So if you have a really tiny pop under ad, yeah, you can actually make people not realize it's still there. The other thing to do is, a lot of the connections, if you're on a large enough ad network, you're just repeatedly finding yourself in the same network over and over and over again. And for most protocols, not all, but most, if your connection dies in the middle, you can resume it. Think about like going to web pages, going to file servers, whatever it takes. If your session dies every few minutes, wait for the next person from that network to show up.
Okay, thank you.
No worries. All right, any other questions? Right there.
Regarding what you said about detection of provider hostility.
Yes.
What do you do when you have detected that your provider is hostile? I mean, you can change your provider, but maybe you may not have that option because it's the only provider that provides DSL service in your area. So
Yeah,
what do you
it's
do?
called tunnel to a real internet service provider.
Okay.
So, you know, a little bit of opinion. I pretty much think this battle is going to end very badly for the carriers. Sooner or later, they're going to war with telecommuting. And let me tell you, saying the world must use more oil is not exactly politically a safe thing to be saying right now. Do we have any other questions? All right, guys, ping me later, especially if you've got any thoughts of audio visualization. You've been a blast.